This is lesson 3 of the algebra topic. This lesson will be looking at multiplying and dividing algebraic terms. With this set exercise, it will be exercise 2B, but it's from another textbook, namely the Year 9 textbook. So the worksheets that I gave out on the Tuesday, that's what you will rely on. But if you didn't get a copy, you can either borrow a copy from somebody who did receive that work, or alternatively you can go into Compass and it should be within the topic of algebra. So this exercise, multiplying and dividing, we have to know that just like with basic numbers and basic digits, multiplying and dividing terms have a set of unique rules that we must adhere to in order for expressions to make mathematical sense. Okay, so multiplying is considered the really simple one. Dividing, still simple, a few little things we have to consider here and there, but still a relatively simple process. Okay, so when we multiply, the first thing we're going to do is we're going to multiply the numbers together if there are any, when two terms are multiplied together. And then afterwards, we multiply the letters afterwards. This step right here is considered one of the easiest, okay? And then with dividing, when we divide, write as a fraction if it's not in the fraction form. Your sheet might say write a fraction is not, but it should say if not. Then simplify the number section of the fraction if it is possible to simplify. Okay. And then second step is that each time a letter appears in the numerator on the top and the denominator on the bottom, it technically cancels out. Okay. Really what technically does happen is it actually turns into a 1, but multiplying any number or term by 1 will result as the same number. Now this sentence might be considered a bit confusing, but this will make sense once we do the examples. Okay, so the examples I've got on the right hand side here. So example 1 is simplify the following expressions. So the question you'll have in the textbook is simplify the following expressions. In this case, we're doing multiplication. Okay. So with the first one, this is saying that, let me get my brush tool out. This is saying 5g times 8g. Or in other words, this is 5 times g times 8 times g. Got to remember that there are invisible times in between the 8 and the g and the 5 and the g. So the first step is implying, for the multiplication, that we multiply the numbers together if there are any. Well, in this case there's a 5 and an 8. So we're going to go ahead and multiply the 5 by the 8. So we get 40. That's the first step. And then the second step says multiply the letters afterwards. Well, we have a G, we have two G's. We're not going to write 2G because the answer as 2G will imply that we are adding the G's together. But in this case, we're multiplying the G's together. So we'll be left with G squared. So your answer is 40G squared. And that's all there is to it. Okay. Second one. Again, with the second one, 2WD times 3WT. I can write the expanded version out, 2 times W times D times 3, etc., but I'm just going to apply these steps straight away to see what answer I get. So we have a 2, we have a 3, multiply those two together to give us 6. How many W's are there? There's 2 and they're being multiplied together. So it's W squared. How many D's are there? There is 1. How many T's are there? There is 1. And that's it. That's all there is for that answer. You could alternatively write 6 dw squared t, or dtw squared, or tw squared d. Doesn't matter which order of the letters, that's fine. As long as the 6 is out in the front, that's all that matters. And the third and last example for multiplication, we have a negative 6 HP times negative 3 HP. I've put this in brackets to indicate that it is a negative number, so you don't get confused. So first step, multiply the numbers together, if any. We have a negative 6 multiplied with a negative 3. Two negatives when multiplied will give me a positive, and 6 times 3 will give me 18. So our answer is positive 18. We have a H and a H, so we have two H's, so H squared, and we got a letter P here, there's two of them, so it is P squared. And that's all there is to it. Now, sometimes your answer might pop up on in the textbook as 18, and then in bracket they'll put H, P, close bracket, all of that squared. These two here indicate the same thing. This is just saying that the H is squared and the P is squared, so I'm going to put it all together and put a little squared there. Okay, I don't care which format you put it in when you do your SAC, because they both suffice as the same answer. Okay. Alright, so that is the multiplication part. I'm going to go ahead and make the division questions readily available. Okay, division questions. Division questions require different steps, so just be careful that you're not reading multiplication, but you're on division. So, we are going to simplify 2n over 4, or 2n divided by 4. Write as a fraction if not, in this case it is a fraction. Then simplify the number section of the fraction. So we're just going to forget about the n for now, and we're going to see if we can rewrite 12 over 4 or simplify it. Now this 12 over 4 is just 12 divided by 4, which is 3. Okay, and if you want to see it as an improper fraction, how many denominators go into the numerator? And in this case 3 in your remainder? Not really. So in this case we have a 3. Each time a letter appears in the numerator and the denominator, it cancels out. Do we have a letter in the numerator and the denominator? Not necessarily. We just have it at the numerator on the top spot, so it just stays as normal. That's our answer. That's all there is to it. It's just 3n. Where it gets a bit tricky is when this scenario does happen for number 2, and in this case we do have it happening. And I want to show you what is exactly going on when we do this cancellation. Okay, so we're going to simplify this division. So the first thing is we're going to write it as a fraction, which we have. Simplify any number section. There's no number section. There's no number in front of these variables, so we can just jump straight to letter 2. Each time a letter appears in the numerator and the denominator, it cancels out. Now, a lot of students might see, okay, there is a b on the numerator and a b on the denominator. It technically cancels out. This isn't necessarily the case. This b to the power 3 can be also written as b times b times b. Then we have a times L at the end, and this is all over b. I have to make sure that I write it out in the expanded version first before I can apply this division rule. Each time a letter appears in the numerator and the denominator, it cancels out. Or in other words, I see one b here with another b here, so I'll first cancel them, and they technically turn into 1s. Okay. I can't really do any more cancelling out. There's no other letters on the bottom. There's only just a few letters on the top. So what I'm left with is a b and a b, which is just b squared. And I have that L that still remains. Now this over 1 when I divide any number by 1, it still remains as that same number. So technically there's no point writing divide 1. I just leave it as is. So all we have done in essence is just cancel 1b out, 1 from the bottom with the top. Well, that power has just gone down by 1. Okay, so b squared L. That's the final answer. And third one, 11mn divided by 2n. Write as a fraction if not. Okay, so this format I do not like. So I want to write it as 11mn over 2n. That's much better. Okay. This division, you're not in junior school anymore, you're in senior school. So this is a format that's required when you write a division. So we're going to write as fraction, then simplify the number section of the fraction if possible. Can 11 over 2 be simplified? Not necessarily. You can't find any 2's within 11 because this is an odd number. So we just leave the number fraction, or the fraction number part of the fraction, sorry, it was a bit of a tongue twister, number part of the fraction, we just leave it as is. Each time a letter appears in the numerator and denominator, it cancels out. So in this case, we have an n and an n on the top, so they get cancelled out and turned into 1's, just like so. So what are we left on the top? 11m, that n's now technically gone, over 2, and no n's, so it's just 11m over 2. And that's our final answer. So that's all there is to it. I might show you a complicated example. Sometimes we might see something that looks like m to the power of 5 n squared t to the power of 3 all over, say for instance, maybe m to the power of 2 n t. This is the case. What you would do is, how many m's on the top? 5, and they're all being multiplied together. How many m's on the bottom? 2. So I would go cancel 1, cancel 2, cancel 1, cancel 2. How many m's will be left on the top? In this case, I would just have 3. There's 2 on the top, 1 on the bottom. So if they cancel out, I'm just left with just 1 n by itself. And 3 on the top for t's, 1 on the bottom. So I'll be left with 2 of them. Or in other words, all I've done was subtract the powers to get my final answer. Okay, that's another way that you can look at it if you do get an example that looks like this. And that concludes lesson 3, multiplying and dividing algebraic expressions. I'll pop up the log sheet. This is the log sheet, multiplying and dividing. So exercise 2b from the sheet that I gave out. Here are the foundation, standard, and advanced question. Go ahead and give these questions an attempt and see how you guys go.